What's going on, fellas? Hope y'all are doing great. Today we're gonna learn about how to factor by grouping. Now we're gonna factor quadratic formulas. Um, I'll start off by doing it pretty simple, break it down. But obviously, you guys are real smart, so I'll go ahead and then I'll show you a bit quicker, a very easier method to do it. So basically, today we're gonna be working without any coefficients. I'll soon drop a video with coefficients. But yeah, for now, there's nothing here. There's nothing right there. So without any coefficient, you want to look at the second term and the third term. The second term always being a variable with a coefficient and then a constant. And what we want to do is, what are two numbers that can multiply to give us this 8, yet add or subtract to give us this 6? Now, what we do if we were to set all the pairs that we have, there's only two pairs of integers that would give us 8 and 6, those being 1 and 8 or 8 and 1, and then 2 and 4 or 4 and 2. Now, no matter how many times you add or subtract 8 and 1, you'll never get 6. You just can't. However, you go ahead, add 2 and 4, you will get 6. So what you want to do is go ahead and rewrite it as x squared plus either 4x or 2x. It doesn't really matter which one comes first. Plus 2x plus 8. Now, obviously these equations, this one and the one right above, are equivalent. All we did was break up the 6x into a 4x and 2x. So, what we really did was kind of make two separate parts of the equation. We have an x squared plus a 4x in one part of it, and then a positive 2x plus 8 in the other part. And if you guys remember, a GCF, the greatest common factor, you want to take that out of each pair. So the GCF in the first part of this equation is an x, meaning if you divide both terms by x, you're going to get x plus 4, because x squared divided by x, 4x divided by x, 4, just breaking it up as simple as possible. And in the second part of the equation, our GCF is going to be 2. And if you divide both terms by 2, you'll be left with x plus 4. Now this is good. You want both parts of the equation and the parentheses to be equivalent, because that's going to be that's going to be one of the groups. And then the other group is simply just putting these GCFs together. So if you put the x and then the 2x right here together, that gives you x plus 2. And then the guys that are already in parentheses, you just count them as 1, and that will give you x plus 4. And so congratulations, you went ahead, factored by grouping, and you broke up this equation, factored it out into these, x plus 2 and x plus 4. If you want to check, you just FOIL the front, outer, inner, last to give you x squared. Whoops, that was the last. X squared plus 4x plus 2x plus 8. I'll just write it out. That will give you, when simplifying, the same equation we started with. So yeah, now I'm going to go ahead and show you guys a much easier way to solve these problems. Alright, let's go ahead and cut out some of the busy work. Now, right above us, I already did part of this step. Basically, once again, there's no coefficient, and oh my gosh, there's subtraction symbols. We have to subtract, and minus is horrible, but it's actually just going to be a lot easier because we're going to skip all the boring parts. So once again, we want numbers that are a pair of numbers that can multiply to give us our constant, yet add and give us our second term. And that gives us negative 10 and 1, negative 5 and 2, and because they're negative, you kind of just flip them around to get negative 1, 10, negative 2 and 5. And now the winner here is going to be negative 5 and 2, and not negative 2 and 5, because if you were to add negative 2 and 5, you get 3. Well, this one will give us negative 3, and we have to keep in mind that minus sign right there. So we could go ahead and rewrite it, but instead, we could really jump straight to our answer. Yeah, if we go ahead and we know it's a negative 5, so x minus 5 is one group, the other one, x plus 2. That is literally our answer. That's how easy it has to be. And if you just keep doing these, this part becomes extremely easy. And you can FOIL, check, do whatever you want. You will get the same quadratic equation that you started with. In this case, x squared minus 3 after adding the negative 5 and positive 2 minus 3x minus 10. So that's our shortcut. We're just going to try it out on one last problem. All right, so to cap it all off, we have one last problem. These below are all the numbers that can multiply to give us positive 6, including two negative numbers, because as we know, two negative numbers multiplied will give us a positive. And they're the only possible pairs that can, when added, will give us a negative number. So we could immediately eliminate any positive pairs, because no matter how many adding you do, they'll never equal a negative number. However, up here at our negative pairs, we know negative 3 and negative 2, add them together, you get negative 5. So once again, you just plug it straight in, leaving an x plus or minus one of the terms, and then another x plus or minus one of the terms. So yeah, I wanted you guys to be able to see what's it like with two positive numbers, a negative and a positive, and then two negatives in each group. Hopefully that helped. If not, please don't cyberbully me. I'll do another video with coefficients in this term, so something like this, even though I don't think this is a positive using by grouping. But point is, I'll drop another video with coefficients, and have a great day. Bye-bye.